In this video, I'm going to talk about literal expressions, but in order to talk about a literal expression, I have to start by talking about literal equations, because when you solve a literal equation, your answer is a literal expression, and the literal expression can often be written in different ways. And that's why we're going to talk about literal expressions first. So a literal equation is an equation that has at least two different letters that stand for variables. Here's an example of a literal equation. Most people have seen this. It's for the perimeter of a rectangle. And we have three letters here, P, L, and W, and they all stand for different variables, perimeter, length, and width. Here's another literal equation that we've used previously in the semester. This is for the future value of an investment that's continuously compounded. One thing I just want to point out is that even though we have 5 letters here, only 4 of them are variable. The E is constant. It's just the value that's close to 2.718. Here's a third example. It's one that we've used often in the semester for different functions. And here we have two different variables, x and y. Now there's some notation issues for literal expressions and literal equations. The first is that capital letters and small letters are standing for different things. For instance, here the profit and the price are related. And we've used the letter P for both because they both start with the letter P. But the capital P stands in this case for profit and the lowercase for price. And so again, even though the letters are the same, uppercase and lowercase are standing for different things. If you have a letter with a subscript, it's different than a letter without. So here, for instance, A sub naught. Naught is an old word for 0. A sub naught is different from A. And the same letter with different subscripts represent two different instances. We've seen this with the slope formula, for instance, where we had x1 and x2 and y1 and y2, and both of those x's come from the same set of numbers. It's the real numbers on the x-axis, for instance, but the x1 and the x2 imply that it's two different x values. Now a literal equation is solved for one of the variables when that variable is isolated. For instance, in this equation, it's solved for P. Now we can rewrite this and solve it for L, and we can also rewrite it and solve it for W. Now sometimes what's going to happen is you're going to solve a literal equation, and the solution will be a literal expression, and then you'll look at the answer, and the answer and your answer won't look the same. And that's the intent of this section of the textbook, is to show you how to rewrite answers into different looking formats. For instance, in the next video, we're going to start with this expression, that is, we've solved this equation for L, but we're going to prefer maybe this form. So there's a way to algebraically manipulate this expression so that it looks like this. Another common thing that happens is if there's a lot of negatives and subtractions, often people want to rewrite it with less of those. Or here's another example which we can rewrite into a different look. They're the same mathematically. It's just that sometimes you want to change the way your expressions look. So that's an introduction to literal expressions. In the next video, we're going to start rewriting literal expressions, for instance, first by rewriting fractions.